Hello? Oi, that's good. I'll just have a little yap while people are still coming in. You've been listening to the ting-tings. I tried to find a song that talked about REST, but oddly enough, there is no song that talks about REST. All right? It did talk about a 4-letter name, and it talked about something that's not my name, which if you talk to people who talk about REST, they discuss whether you really are doing REST. It's like the Agile thing. We do Agile, you don't do Agile. We do Agile. No, you don't do Agile. The whole discussion kind of carries on. So hopefully we're all here to see about REST. You might have different opinions about it, whether it's good or not. The important bit is we're talking about it in the context of really consuming public APIs and designing them. And there's a good reason for that, is REST is actually really quite useful for doing public APIs. If you are internal in a company and you own all the servers and it's all on a heterogeneous network, you may not go for REST as the best option for inter-process communication. You might go for gRPC or direct cut sockets and things like that, because it actually would probably be faster and not as much as an overhead. So it's not a one-size-fits-all. So we're really talking about public APIs. I ought to say why I could talk about this. So I work for a company called Huddle. Was anyone at Ian Cooper's talk? Damn, I can't really talk about how he talked about Huddle. Huddle does secure document collaboration. So it's kind of where a company can invite external people in to share documents, and you can find out who's viewed them, who's downloaded them, audits, workflows, things like that. Well, I'm not working at Huddle, where I've been for 5 years, helping with the clients who consume the APIs more than anything. I'm sometimes on a bicycle, doing commuting into work, 10,000 kilometers a year, fall off about twice and get scratched and horrify people with bruises. And this morning I was completely mad, and at 7 o'clock I was running up the river in Oslo, that's from this morning. There's a really nice river you can kind of run up. So that was a good laugh. So, what do we mean by REST, clearly? That's what we're going to start with. Roy Fielding was the guy who did the original proposal. He did it in a thesis. It's part of why he's Dr. Roy Fielding. He also coined the term Hypermedia as the engine of application state, which has to be one of the worst acronyms ever created. They have since said, we don't like having an acronym with the word hate in, because that, ever since Donald Trump got elected, no. So it's now known as Hypermedia API, so no one has to work out how even to say HATEOAS type thing anyway. And you may or may not have heard, anyone heard of the Richardson maturity model? Well, there's this whole idea of how RESTful are you? Are you going for resources? Are you doing resources with verbs? All sorts of levels of maturity. Now, according to Roy, Hypermedia is the thing that is REST. It's not an option not to do the links that link you to the next resource, and the resource should provide all the onward information. Just like a web page, Hypermedia is how a web page works. You might go to bbc.com, find news stories, but you can't predict any of the links you're going to see, but you can click on them and go further in, and find news that you want to find, but you didn't have to know all the links. You only had to know the entry point. So Huddle works in a similar way. You get an entry point into Huddle. Once you've got that, it tells you where everything lives. And theoretically, we could change that, because we could trust all of our consumers to not hard code APIs and put IDs in them. Yes, like we could. So when you start discussing levels of maturity of REST, how you do REST, what's the exact correct way to do it, you get what I call RESTatherian arguments. I was writing this just before I went to Barbados, so I decided to put REST in. And it's like real arguments about whether it is REST. Should that API do this? Is that verb applicable? Quite heated arguments. But you really got to go back to Roy Fielding, who invented it. And unbelievably, it seems to be one of the terms that's never been redefined by Martin Fowler to be something different, which I find quite amusing in the industry. And one of the guys, Mark Amundsen, has tweeted about REST versus CRUD, because one of the misconceptions is REST, well, it's just CRUD, isn't it? You do a get, that's like a select. You do a put, that's an update. A post is an insert. And a delete verb is delete. And it's CRUD. You know, and that's what you first think when you go into it, and then you realize it's not CRUD. And the really important thing he highlighted with REST is that when you're designing your web API, your data model is not necessarily your object model. So you have databases. You probably instantiate stuff from databases into classes and objects. You don't necessarily have a one-to-one mapping unless you've got some ORM mapper of that column means this property on that object. You might have data access layers that translate between them. And in the same way, REST, a resource is not necessarily the object you have in your object model, and it's definitely not necessarily a table in the database. So the moment you free your mind from that, we get away from the idea that it's just CRUD, and we can actually do business processes and operations on them, and we talk about resources. So for those who don't know about REST deeply, I'm going to go a brief thing of what a REST request would look like and what a response would look like. A REST request is a HTTP operation on a resource. For pedants, and this is from my colleague at Huddle, Toby Henderson, who helped me quite a bit on this and gave me a few examples. It doesn't have to be HTTP. It could be over a message bus. It could be over any other thing. But for the rest of this talk, it's only going to be HTTP, because that's what everyone is probably using. Anyone use REST not on HTTP? There you are. Thought so. Mythically, it cannot be on HTTP. So you get something like this. You do a get on a URI. For Huddle, it's api.huddle.net, files, users, 123, recent item. So an item you might have looked at recently. You know it's called a URI or a URL, a universal resource indicator or locator. So it's a resource. That's our resource, that URI. And at the end of that, we go, here's my authorization, maybe. So these are in headers. You might have an if modified since, because you know you got it recently, and you want to check whether anything's been updated, and you don't want a heavy response if it hasn't been updated, so you can do caching. And then in the body of it, it might be JSON, it might be XML, but we've got REST responses that deliver CSV files. You ask for application CSV, and you get back CSV. So nothing says it has to be JSON at all. It helps if it's JSON if you're going to do hypermedia with lots of links in, or XML, if you want people to find it harder to read. So, and the anatomy of a REST response looks a bit like this. The kind of thing you get used to looking at in Fiddler and in network diagnostics. So you get back a status, maybe 200 OK, because it's found the resource and it's all you've authorized and it's all fine. You might get a content type telling you what kind of content is being delivered. A last modified header, which allows you to do caching on your side as well as the server knowing about it. Might be JSON, XML, as I said, could be even CSV, could be even a PDF file or a Word document. And if you've got this JSON or XML, you might get a set of links. So you can see here we have a link for deleting a document. We have a link that tells you how to get the document, that's self. There's an alternate, which allows you to open it in the website. So if you want to open that document in a web browser and go to the exact page in Huddle's website, that's the alternate link. And there's known names for these rels that people use that you try and stick to by convention rather than as a specification. Now, someone's going to say, well, we shouldn't always, but there's new things on the block. There's gRPC rather than REST. We've had people leave Huddle and come back with the joys of gRPC. If you don't know what gRPC is, Google have created an open source RPC engine. It's always connected, HTTP2. It's using a binary protocol. And it's procedure-based rather than that kind of resource-based. It's the old-fashioned RPC. I think we saw RPC with Java RMI and Corba and DCOM and SOAP. Did anyone do DCOM and SOAP and Corba? Yeah. Does this ring true? You weren't there, man. You weren't there. Right. I don't want to go back to RPC days. Everyone pretending the object exists on your machine, but it's on that remote machine over there, and God knows how we debug the crap out of this. Right? So I'm going to skip RPC because I'm talking about public APIs, which are much harder to do with something like that when you can't guarantee the HTTP2 transport protocol is going to be around. So if you're going to start designing an API, I mean, where do you start? Well, I think the first thing you do is you do not start in a code editor, because that's a bad thing. Especially if what you do is take your data model and just fling it out as a kind of API and make it almost CRUD-like, because that's possibly not going to be the best solution. It might be for admin pages, but for anything that's high stress, anything that's going to be used quite a bit, it's not going to be maybe the best solution. So you should be considering your human and automated users. Human users are the kind of people who would use a website. How are they going to flow around an application or an iOS device or an Android? The automated users are those services that some of your customers will use, which will hammer the crap out of your system, because they want to just automate things and sync files and get the latest tasks and drop everything into their own system. And they have quite different requirements to people who click through an interface and are trying to navigate around an application. So you should kind of make your API readable by a human. SOAP and XML weren't inherently readable, unless you could just translate the braces out. And while you have the model on the server, it may not fit all your clients. So this is quite interesting. Do you design for the server, for the client? You're really designing for the business. You're trying to do what are the things that most people are going to use, how efficient can we make it? And you've got that boring thing of security, reliability, and speed, and you can't have all of them, so you've got to make some compromises, which is why you set up a Slack channel where you can argue the crap out of this for several days, propose APIs, amend them, change them, all without doing the code first, before you finally go, hey, this is the API that satisfies no one, but it's the best we're going to get away with, right? Because no one can ever agree on the perfect API. And the really important bit, while you're going to do that design upfront bit, is you really are creating a contract. And it's a contract between a publisher and a consumer, and it's creating mutual obligations. Because for the person publishing, and that's for Huddle, we have to document the API. We have to tell people, where are our resources? What do we expect to give you back? What are the options you might have? What might we extend? Because it was nice to give hints. And how different clients might use the API, because different clients have different requirements. For the person consuming the AI, if someone has documented the API, please read it. I know a document's boring, but it's really hard to write the documentation. It's really important to read it afterwards, because you can get really into a tangle without doing that. If the guys who've written the API haven't documented it fully, moan at them and get them to document it fully. If it's open source, do pull requests on their documentation and get them to have nicer documentation, because they quite enjoy that, because that's the bit they don't like writing. And remember that if you only need certain bits from the API, only use those bits. Don't try and consume the whole API up front. Try and be agile about it. We only need these bits at the moment. Those are the bits we'll take. If you do that and reduce that coupling, if, God forbid, they change something that's really a breaking change, but you don't use it, you won't care. And you're fine, and you'll survive it. And documentation is the key. So I don't know how many people actually create APIs. Quite a lot. Woo. Because the documentation is the key at that point. And however, even if the documentation is sample code that shows you how to use it, that's going to be a winner on it, because that just leads people the right way into using your API. Because there are ways that people can use your API that you never thought of, which will then tie you in knots later if you ever needed to change it. Which includes the concept of versioning. Versioning is a real problem with REST, because you know you've got the ultimate easy way of versioning when the URI has v2, v3, v4 written in it, and the resources are all different for all the different Vs. And the clients have to know about all that, and they have to be all maintained, which is actually quite a lot of work at the back end. So on the Nordic API website, which is a superb website for discussing REST and APIs and good practices, and Nemec, I'm not going to say his first name because I'm rubbish. What versions exist? Quite a lot, annoyingly. the version of the API that the clients are expecting, what message format it might have in it, the server, the documentation, what version is that describing? But what you don't have is you shouldn't really be putting this v2, v3 in the resource URI. That isn't where the versioning is. A document is a document. It might be it's described slightly differently, but if you've done it correctly and you've made optional parameters and things like that, you should be able to get away with upgrading without a new version. So that's what you're trying to do. And if you've got radically new and different versions of resources, you really need different resource URIs because they're no longer the same thing. So how do you extend an API? Apparently, you must not take anything away. You must not change the processing rules. And you must not make optional things required. I mean, this sounds really obvious. So, and the thing is, it's anything. It's the data in the JSON, the methods that might be used, the headers, all sorts of things can actually effectively change an API. But you can monitor who's using your API. Now, this is an important bit. It's important that if you have external customers, you know who's using an API and who isn't using an API. So you have something like GDPR coming up, which we had. And we had an iOS contacts app. We wanted to work out, realistically, it was an old app that we'd put out 2 years ago that allowed you to find all the people who were in Huddle in your company and be able to look them up. And we went, it's a GDPR nightmare. It's local data on people's phones, and it's all the personal information. So let's see who's using this app to work out what we're going to do with it. And what we find is there's about 5 people using the app. At which point we killed the app. So we said, pull it out of the store, warn them, give them 2 weeks' notice, we'll just kill the app. It's on an old API version that we don't support properly anymore anyway, to get that list of contacts. And it was much easier just to kill it off. But we could only do that because we know exactly who's talking to our API, what they're calling, and then could work out exact users who are calling it, so we could email those users to tell them we're about to deprecate an API. And unbelievably, telling someone we're getting rid of the app that someone's using got us good marks in Zendesk from the customer supports telling them that they were going to withdraw the product. And that's part of it. You formalize how you're going to tell people you're going to change an API. For us, you've got at least 6 months before you could ditch an API that you don't want to give someone anymore. At least 6 months. Just to flush all the clients out and flush all the systems through. And that includes the applications we write that people install on their machines. So you can't force everyone overnight to upgrade their iOS app. They're not going to do it. And enterprises really don't like upgrading desktop apps every 2 weeks. That's something they resist hugely. So there's this idea of introducing these breaking changes. So you create a new resource if you're going to change query parameters and what it might do, headers, what data you accept or send, things that you rely on, and relationships with other resources. If documents don't live in a workspace anymore, but they live somewhere completely different, and you're going to give someone a completely different resource for who owns them, you're going to have to change the resource, because the old clients won't know what to do with it. Basically, if you can't make the client app produce the same results with the same resources they previously called, you've broken the API. You've done a breaking change. It may be they still behave correctly, but they make a lot more calls into your server, which is one of the cases. So what we're trying to get is patterns and strategies that we might reasonably go for to make our REST API friendly and nice. And in that versioning, we have things like deprecation. Obviously, I said we give people warnings. You give people 6 months. Even after 6 months, what you really don't want to do is start giving them server error 500s. We want to get rid of that. That's a nasty thing to give a client because it doesn't really help them. Because what happens is the user blames whatever the app is. That isn't necessarily them. It's maybe Huddle. They might not even get to the idea that Huddle's at fault. Or they might just say, Huddle's broken, I can't get to it. That's it, I'm not using it. So you can do elegant deprecation. So if anyone used Google Capture in their login forms in order to do validation, at some point this year, early on this year, The capture, which would normally be that random squiggle of letters and numbers, it's hard to read, so computers can't read it, but a human can, started to say this to 1% of users. So it would come up on something like a login page saying, v1 unsupported, please tell whoever it is who's written this site to go to this URI. So after that URI, and it tells you, hey, you need to upgrade from v1 to v2 of the capture interface. It'll all end in March, and March you won't get anything at all back. And that meant we could tell the site owner, by the way, you need to upgrade your capture thing, which is a relatively easy thing for them to do. But that's a graceful deprecation where even when v1 was still available, they selected 1% of users to show that message to get those people off v1, which is kind of really neat. Now, did anyone, I was going to say, does anyone have a Windows mobile? But I think it's got to be the past tense now. Did anyone have a Windows mobile? And you used to be able to search for music, like Shazam. You could make it listen to a song and find out, what song was playing. They got rid of Groove Music in December. Microsoft ended the Groove Music streaming service. And at that point, they couldn't tell what music you had because they had no music catalog to compare against. So when you went and searched for a song, it came back with this. So whatever song you searched for, it came back with a title for that song of song unrecognized. On an album, the service is retired. By the artist, music continues, right? That wasn't just mobile. That was on Windows 10 desktop as well, because this was Cortana's music search feature as well. So it actually happened on real desktop machines just as well. But the point about that is the user gets a message that completely tells them kind of what's happening, that clearly this service doesn't exist anymore, but they can still play music, but what they can't do is recognize it anymore. And that's nicer than server error, I'm going to show you an empty list, which is otherwise what happens. And one of the ways you achieve this, has anyone heard of BFFs? Ooh, yeah, a few. Back-end for front-ends. So it's this bizarre thing. It's basically a facade in front of your own services. So you may have an API already, and you want to deprecate how the API works, mainly because you're completely re-engineering the back end. We've done this recently. We re-engineered entirely how our task system works. It means we don't really have the same data anymore in the database that we used to have. So to support the other API, we've written a Python front end in front that calls the new API, but translates it into all the semantics that the old API would have done. And that means we don't have to support the old API in a honky bit of C# code. We can temporarily support it in this Python until we move everyone off, and then we can throw that Python away. And you can do the same thing with Node.js or GraphQL. It's that kind of thing where you put a temporary facade in front. So this is just great. It was in the ThoughtWorks Tech Radar in 2016. As finally, I know quite a few people who are now using it as a pattern. So you could re-engineer and just use the new API, but hand over as if it was the old API. The other thing you can use BFFs for, and Sam Newman was wittering on about this about 4 years ago at an NDC workshop, is those BFFs are good for things like changing the shape of the data. If your REST API doesn't quite do what you might like for one of your clients, one of your apps, you may decide we could put a BFF in front of that. So the front-end team who write the web, they're good at Node.js. They can make Node.js or GraphQL, talk to our APIs, and so when they ask for, give me my recent documents, instead of going a recent document list, 20 document links, and going through every document link, they could just return an aggregate of all the 20 documents, which is something they can write in their BFF, and then supply a much shorter call into their web client, and then it only has the data that they need. And that's their strategy, is to improve performance by doing optimizations on really recent, commonly used things that take a lot of time. Now, I said about hypermedia. We know that hypermedia in a normal web page gives you the links. So I did the example of a news site where you click on the headlines and you get the top 10 headlines, and then you click on them and work your way through. So when you deliver a resource, you can do these links, and that can tell you how you should construct the user interface. So we can work out if a user's allowed to edit a document, We could have edit links. They could have a delete link. This actually allows you to build the interface based on the response you get back. This is really cool stuff, because it just means you don't have to go to a different permissions engine to go, right, now I've got a document, I now have to go off and make this second call and find out how I should make my user interface in order to work. And that just allows you to build this interface. And all the links that come back, all those hypermedia links are relative. They can change. They could theoretically change so that they can be upgraded. And they really reflect the permission you have on a document. So we use this in a real-world example in Huddle. And we use it especially in our document page. So you're looking at a document. You need to know whether you can edit it, approve it, do things. All those links are set by the user's permissions. The only problem is we cocked up a bit, because we didn't just use it for permissions. So one of the things you can do in Huddle is lock a document for editing. And that's a single lock. That's what we implement internally. We can also do multiple locking using Office 365, so you can edit online and have multiple users editing the same document, but this is a single lock. And the problem was, in the old days, we just kind of loaded the document page, and if the edit link wasn't there, you couldn't edit it, probably because it might be locked, and it might be because you don't have permissions. But you don't know, but it doesn't matter because we don't need the edit button. And you'd refresh the page in order to see a new version of it to see if someone had unlocked it. We then got all excited, and we got WebSockets in there, and it's now a single-page application, so it doesn't reload. It magically gets told the document's been updated, so it knows it's got unlocked. And so the team go, it's great, we've got an unlock message. We can enable the edit button that we don't have because we were never given it, because now we haven't got that because we never had it when we entered the page because the document was locked. Bit crap. We have to reload the entire document resource in order to work out what the link the edit button should have had. So we're now in the process of working out how we're going to have to extend the API for documents to include a section that's new that we will understand as this new bit that tells you, hey, here's the edit link for when the document's unlocked, so that we have something we can show immediately. And then we can drop a call out of the web browser, and it's really fast, and the button looks disabled to start with, which indicates you could have edited it, but someone's got it locked, which is how it works if you start with it being unlocked, and then it locks automatically. Because we cache all that document information in a local repository in JavaScript. So the other thing that I highly recommend if you aren't doing it is get hold of the idea of doing 304 not modified. So it's using this if modified since and last modified headers. These are really cool and will save your server a lot of effort. So basically what happens is when you get a resource, as a publisher, you can give someone a last modified header. So it has a date, time type thing in it. And that allows you, the client, to say, hey, when I next get this document, I had this last modified header. I'm going to say, if it's modified since then, can you tell me? And if it's been modified, you get a 200 and you get the full JSON back. If it hasn't been modified, you get 304, and the client says, I've got the latest version of this. I don't need any more. And that 304 for Huddle is a check in Redis. It's really fast to do a lookup. We don't have to go anywhere near our main DB. We don't have to go anywhere near loading real data and comparing it. The other way you can do this is with e-tags. E-tags are absolutely the way you would guarantee it's not being modified, where you hash all the data you would have given in the JSON response or the response. The only problem with hashing all the response is you have to get all the data to create the response, to create the hash, to check whether it's changed, which is quite a lengthy process. So there's something called weak e-tags, where you do a version number. So you actually hash, this is document 20. If you've had document 20, you've probably got all the data. And that's a much faster operation to do. So that's your solution if you don't like the not modified. If you're a really busy website, there's a problem with not modified. And the not modified problem is it's based on seconds. And the problem with that is if you have someone update a document at 21 seconds, and someone read it, and they get, yeah, it was modified at 21 seconds, and then someone else comes in half a second later and modifies it, and then you ask for it again, you'll be told it hasn't changed. So if you've got really busy sites, you're not going to be liking the last modified header. You may find you get very weird edge cases where you don't get the latest data. At that point, you've got to go e-tags. So here's an example of where our BFF broke the API, unfortunately. Remember I said it's not just the resources, it's not just the JSON, it can be the headers. The team who made the BFF decided to omit there being a last modified header. So our iOS app said, hey, have I got any notifications? And it said, yes, here, 200. And it said, right, I've got 20 notifications. I'll hammer the server for every 20 of them and get all the data to do with them. What it didn't do is put 304 logic on the request for notifications, because it didn't need to, because the list kind of dealt with that. So unfortunately, it gave the same result in the iOS app, but it was making 21 calls instead of 1, which is a bit unfortunate. To be honest, we could have left it like that. There aren't that many iOS apps on that particular page in the app causing us the problem. But the mitigation is clearly put the last modified header in because you broke the API. And there was a belief that we shouldn't need to do that. The client's got it wrong. And as I said earlier, if the client behaves differently because you've changed something in the API, you've broken the API. You've made a breaking change. The other alternative, as they said, was, can you just fix the iOS app? I said, do you want to wait 6 months for us to get everyone onto the new iOS app? And they went, no, not really. I guess, no, you're going to have to put the last modified header in, which wasn't too hard. So one of the other things you can do, has anyone used returning 429s when their server gets busy? It's cool. How many people respect 429s? Who's used it? Do you find people don't respect them very much? So the whole idea here is, if your server's really busy, and you can do this rate limit on specific apps, is one of the interesting use cases we have. We have a company who wants to sync all the files out of Huddle onto their local backup systems all the time, and they make a lot of requests into the system, so we rate limit them. We allow them to make so many requests per hour, and we can monitor that, and then we can rate limit them at the point they start exceeding their usage. So what you do is you send back 429 with a header saying, hey, retry in 30 seconds, and then try and come back in. And if your consumers are nice, they back off for 30 seconds, and then come back and try and request again. And that's really cool for trying to, if your server's under pressure, you can start relieving it by just saying, hey, we're going to start rate limiting people, get the system back under control, and then we should be okay. There is a responsibility of the consumer to actually do something sensible with a 429 response. Unfortunately, at one point, we managed to get our desktop client trying to DDoS us because it was hammering us so hard, because we had problems on the server, which meant the server timed out. It thought the network had gone down, checked whether the network had really gone down, found that the network hadn't gone down, and came back and forgot to do a 304 and requested like hell for all the data it might have missed in the meantime. And it was very hard to deal with at that point. So, but even with it being hard to deal with, those clients could still get 429s back, which is a faster operation than having to get all the data and then timing out. So 429s can be a very quick thing to protect your server in an emergency. So the other thing we get is, you think, in this modern world, we've got web calls. They're not really async type things. And async's the new, everyone would like async. C#'s given it to the rest of the world in language terms. So how can we do an async pattern inside of REST? And there is a pattern for it. It's a progress endpoint pattern. So it's really nice. So if you're doing something like a search, or say in our system we upload a video and we expect to get a preview of it, but some of these videos are 1 gig in size, it takes time to convert an entire 1 gig MP4 file into a lower bitrate file for people to preview. So you post all the data that you want, the server returns 202 accepted, and gives you a link to say, hey, here's a link you can check to see how it's going, see what's happening. And that's the point. So that link can then either return a final response and give you the JSON. So it's almost like if the post was quick, it would have returned the JSON for the new resource it created. But instead, you keep polling this link, and eventually, when the preview's ready, it will give you all the JSON you would have got if it could have done it like that. Or it could say, we ran out of space, or ran out of time, or we can't convert it because there's a problem with the file. Or it could even just redirect you to the right page, that kind of thing. And when async came in, and someone went, we can async our web calls inside the server. We can make our web calls asynchronous. And wanted the magic thing of, I want to make it asynchronous so that someone can make a call into the web server, and it immediately comes back if everything's OK. But if there's an error, I want them to be held until I give them an error code, which is impossible. The way he was describing it was just never going to work. Whereas this pattern actually works really well. So because we get this progress pattern, we do that original query, that post, that put or get, that causes us to get a redirect or a progress URI. But if we had, oh, that document doesn't exist, or you're not authorized to do this, or there's a server error, we could give that back immediately. So you immediately give fast failure to the client, and then you allow the client to poll later to get the final result. So it gets that whole benefit of that async operation of, right, now the app can just go off and do this complicated query, say, if it's a long search query. You can do other things in the app, and then it can pop up going, hey, that query's finished. Do you want to look at the results? And you can have it all happen in the background. Now, the other thing we've had in the past, and this is a great pattern to use, was when you get just one property you want to change on a resource, just one. And the REST purists go, well, you must do a put with the whole of the resource. That is all the JSON that could possibly be in the resource. You can't just change the status on its own. And the real niggle with that is you then start getting into new verbs such as patch. And you start talking about patch operations. And then, because as well as get and get, put, post, and delete, there's also head and options. And then you get esoteric and start going patch and all these things. And patch is not guaranteed to be idempotent either. So it's a bit painful. And whether your libraries support them properly is another question. So we could do a mini put or post. So we create a child resource. So say you had a document, files document 123, and all we want to do is change the read-only flag, change it from 1 to 0. We put to that new resource, it's just a child resource, and it's just the read-only flag with one property in it, one bit of JSON in it. And then it can return the full representation back, so that we actually get a full version of what that document looks like now with that read-only set. And the really nice thing is if we call it 4 times, we still end up with the same thing happening. It will be the read-only flag set to 1 or 0, the thing that we tried to do. And the point is, when you return the whole of that JSON, we can then use the content location header in the response to tell you, although you put this resource, what you got back is this resource. So go and look over here. And that's what we've actually given you back. So you're not even breaking the whole rules of hypermedia and links and resources. So this is really cool, because that's one of the hardest things to do in REST, where people go, but I can't do something simple. So real-world examples, and we'll go on from that. So this exact example we have was a FileRequest status. So you can create a task in Huddle and say, hey, Bob, I need you to give me the latest financial figures for the company. And he gets an email, and he gets an endpoint that he can upload it to. And at some point, he can set the status to done when he's happy that he's uploaded all the data that he needs to upload. And the guys in the front-end team are going, this is really crap. So, because every time we update the status on the web UI, we have to do a get to the latest version of the task resource to make sure no one has changed it since we loaded it into our web page, to then change one property on it, to do a put, which doesn't return the resource either, because puts don't necessarily return resources, and then we have to do a get to make sure that we did save it correctly so that we can refresh our repository, which is 3 calls to do one tiny frigging operation. To which they said, but that's how the API works. But the good bit was that I then went to coffee with Toby, who is responsible as an architect for the Tasks API, and he said, why the hell didn't they talk to us about it? We'll just write it like this. We'll use this method of doing it. So they're developing that mini put. So there will be a status, child resource, they do a put, they get it back. And the web team are really happy. And why they couldn't walk 4 desks across an office to talk to the back-end team to have a discussion about this, I don't know. But it's my example of how coffee solves everything, if you go for coffee regularly with people. So it reduces server calls, and it clearly actually indicates what the business process was, because I didn't want to update a task. I just wanted to change the status. So I'm much more clear about what I'm trying to do and what I'm attempting. So I mentioned earlier that we shouldn't overconsume. And I'm not talking sugar and fat and alcohol, because everyone should overconsume sugar, fat, and alcohol because they're gorgeous. And they make me happy. But make me have to run in order to get rid of the weight. That's the only problem. So just because a response includes data, you do not need to have it all, right? You don't need to grab it all. And responses are messages. They're not saying, hey, you need to know all this. It's, hey, here's all the information. You can do what you like with it. It's up to you. Especially if you're just reading and you're not really updating things. You don't need all the data for a resource. You only need the subset for you to do with the operations you're interested in. So a real-world example is Huddle Desktop. So a QA who was doing quite a correct thing decided to put an invalid URI in the personal website of the user profile, something we don't support anymore, personal websites. And they were checking we didn't get JavaScript injection. So the server code that accepted the update to a user profile, that was quite happy to have something that wasn't a proper URI. So that's fine. Huddle Desktop, every time it starts, goes to an entry point into our API. As I said, you just go to this entry point, you get told where to go, and what you get told is where the user profile is. So you load that. It decided obviously a personal website must be a system.uri. Pushed it into that. .NET blows up. .NET Framework says, that's not a URI. I can't put it in there. Throws an exception. On the bit of code, they decided not to put an exception handler around. So that's the end of our desktop every time it starts up. So, and the real annoying thing about this, of course, is that desktop did not use the personal website. It never showed it. It never used it. But the problem was, when it was first created, they pointed it at the API and said, we will serialize everything into real objects. So every class deserializes every bit of JSON into an object. Whereas what they needed to do was get about 5 bits of information out of the 20 or 30 that they needed to get. And then they could have survived such madness as JavaScript in a URI. Now, I've been ragging on the desktop team. They had the oldest app. It's 4.5 years old, and it was written with the very old APIs. The Android guys were much more modern. They're about 2 years old. And they have a bit where you have a to-do list of tasks and approvals that are outstanding, and they got a list of tasks that were coming in, and they decided to put this bit of code in, and they said, tasks have a type, an action type. They're either tasks or approvals. If they're not a task or approval, God, we don't know what it is. We've got to throw an exception, right? So what happens? We add file requests. The to-do lists don't work anymore because they decided to throw an exception. Not kill the app. You just get a blank to-do list. They do have exception handling around that. They got that right. It doesn't just kill the app. But this is the point. So a lot of your APIs you'll talk to as a consumer will have enumerations. They might have colors. They might have days of the week, things like that. And what you should really be looking for is if you get a value you're not expecting, you can mitigate it. We could have just shown you the tasks and approvals and possibly said to someone, maybe in the UI, there might be things we can't show you in the to-do list. There's 10 items we can't handle, but at least we can show you the ones we understand. So it's really good to just cope with the things you know about, and if there's things you don't know about, warn the user, but try and carry on, because there's a good chance it'll all work. They also did a very interesting thing. The same guys who did the BFF, where they omitted the last modified header, and cause the iOS app to go rogue. Also had to deal with an Android app that, despite the fact that when you get a set of links, they have rels on to tell you which one does what, decided they'd just go for link number 0 in the array, and that would always be the self-link, because they didn't need to do anything. Now, who here uses single or default or first or default in link queries? Yeah, same bloody thing, right? The assumption is there is only one when you use single or default, and then it blows up when it isn't. They are doing exactly the same kind of attitude. They're not looking for the data they know should be called self. They've decided to just go for the first link, and it all went completely pear-shaped. So the BFF team had to preserve the link order. The lucky bit is it's all in JSON, which preserves link order. XML has no promise that you get the links in the exact same order, that it would deserialize in a DOM to that order. So they're very lucky they could do that. And be specific as a consumer. Now, this isn't actually a REST one, but I had to at some point get this into a talk. It was Huddle Desktop. It was when we were having problems with it coming back into the system. It was when we had 429s, and it was trying to DDoS our own server. And it does this. It does a check for network connectivity, and it says, hey, if I get a server error out of Huddle, I may have lost the internet, because 500s come back from a no network as well, just as much as server errors. So what I'm going to do is we need to check whether the internet's up. And checking whether the internet up is a bit of a pain, because you can't rely on OS libraries to check for a network connectivity, because it may not be the internet, it may only be the intranet that's up. You may be partially network connected, and it has to work on a Mac as well as Windows, which have completely different semantics on how Xamarin would give you a network connection to Windows. So we go off to an Amazon S3 bucket, and we go to a URI that ends in the word ping, and it should return the word pong in the response. Something that's really horrible to explain to clients as they're trying to debug the app, and you're going, put this in, and if it says pong, it's okay. It doesn't say pong anymore. It has a much more enterprise-friendly message about what it's returning. But this bit of code was just classic. There was actually if the status code is less than, bad request. I was like, what the yeah. And that was, so anything under 400, it's fine. Redirects, anything. 200s, whatever it is, accepted. I might not even return you anything. So clearly, this S3 bucket, we deleted the file, or renamed it, and the desktop still kept coming in, thinking the network was there. And it's all because CloudFront in front of that S3 bucket has a default if it doesn't find a file. And the default was to give you JavaScript to redirect your browser to Huddle's website. It's because we were reusing a bucket that's used for something quite different most of the time. So it gave you a 200 and a bunch of JavaScript, and clearly it thought the network was there, so hammered back into our service, so we couldn't turn our desktops off. So mitigation now is we do look for HTTP status code OK, and we look inside the file to see what's in there. So this is the thing. If you get a response back, just because it says 200 doesn't mean you've got exactly what you might think. You should go in and check. Easier with REST, because you're probably binding an object to some JSON, and you might get a clue that it's going wrong. So that's my real-world examples from the field of Huddle. We have our apps and creating stuff. These are really great resources to go to. The Nordic APIs is a great way of finding out about REST APIs and having the kind of seeing the discussions that people have and the thoughts they have. One of the things they were discussing was the idea that although REST is kind of old hat, maybe it's getting to the tipping point where we might get the tools that make it much easier to use. I think one of the resistances to REST we've had is that it can be quite painful to use because you're at a lower level. If we had the ORM type thing, but for REST, but not ORM type thing, because no one wants to do that, we'd be better off. And maybe they think it's the tooling. There's a Slack channel created by Sebastian Lambler, who people may know from OpenRaster and things like that. And that, where you can, I didn't finish the sentence. How terrible. And you can discuss what kind of semantics you should be using in your API, and does this make sense? Is this a good pattern to use? And they're really friendly and actually help you out. And then bizcoder.com leads you to a load of REST patterns, such as the progress end pattern, too many requests, all sorts of things like that. So we're starting to get known patterns for REST documented really clearly that everyone can use. And I think that's really cool. And the REST cookbook as well gives you a really good focus on it. So I blog occasionally at that, and that and the Twitter was where you'll find this presentation. I'll get it uploaded to GitHub, now owned by Microsoft. And that's where you'll be able to download it in a few days. And if you ever want to see about Huddle, you can, working for us in London, you can go to there. And that's it. I think I finished early, which is shocking for me. So, is there any questions that you think I could answer? Go on.
Question. When you get a resource, you want to update it and then put it back.
Yeah.
But we also should only look at the things you actually need. Do we always need to create those mini puts, or do we need to round trip everything?
Right. So the question is, when we get a resource, if we only get the little bits of information we need, how can we then do an update to it if we don't have the mini puts, those little child resources? And the answer is, you're hoping that 95% of the time, you actually only need the get, and you can minimize that information. You either are going to have to make the child resource for a mini put, or more likely, the number of writes you do are so smaller compared to the reads that you can go and get the full resource and then do the write back. And I think that's a trade-off only you'll be able to work out. So I know our databases, it's 98% read, 2% write. You really don't write a lot to a database. So if you're lucky, you're in that situation, I think you get the full resource, put in a status and put it back. But if it's something that's needed to be quick and slick in a UI, you might want to do the mini put. That's when you start going for that, because it's the performance thing of when the user clicks, oh, I'm approving it, and it takes 3 seconds to do the whole shebang. That's unpleasant for a user to watch when you could fix it so easily. So the question was, how much do we nest resources in a REST API? Which is a good question. So when we have a document, and we get back a document's title, its name, things like that, we also then have a list of actors. So we have a list of users, who created it, who's the last person to update it, things like that. And they are mini resources of that kind of user. So it tells you a self-link to go to that user profile. It has a link to their avatar. It has their email and a few bits of information, enough information for us to do the UI we want to do in our clients. And that's kind of why we're doing it. We're trying to do a minimal amount so that if you saw an activity trail under a document, you see people's avatars and you see their names. So if you hover over them, you can see who it was that updated the document. And you can click on it to go to a full profile. So that's the bit where you don't want to, it's a bit like if you use an ORM with child objects and it populates automatically all the child objects, you want to resist that. You want to do this minimal consuming of the child items out of your resource. Otherwise, you will end up with a very deep model with a lot of data. And although the transfer over the web is fine because it's gzipped and it's really fast, you know, the chances are it's compressed in all your HTTP calls. It's the unpacking of it into huge local objects when all you needed was a tiny bit. I don't think that's the pleasant bit, and browsers don't like that particularly. So I would put as little as you can get away with always a self-link to get the full information if a client needs to get the information of that child object. Mm-hmm. Okay, thank you very much. Thank you.